Okay. The processor that we will use as example, and we will have the tools associated with this processor, which we will be introduced next week. Okay, where that we write more concrete program and really run it. Today we thought of explaining and writing the program using pen and pencil method. That means we cannot really test it. Okay, it will be a simplified form of understanding this set of instructions. All right. The processor I will use, an example is called S2. I have been playing with this design for more than 10 years and use it in several classes already. It is a 32-bit processor, right? A simple one, and it has a modern style of instruction format, which is 3 address instruction. It has 32 register, and all the operation are done on register and with the 2 instruction that retrieve value from the memory into register. Okay. Next slide show you the structure of this processor. This is important to understand how the processor works, but you may let me manage the sound a little bit. Okay, it's okay. Right. Okay, I think it's all good, and it's you require to understand this diagram a little bit. So let's I will cut this diagram into 2 parts. Okay, the top part is I call what I call outside circle, right? And the bottom part we call the inside circle. Inside circle composed of register bank, ALU. Okay, so the data go from register bank to ALU to perform some operation like adding 2 numbers together, and then go back to register bank. Okay, this is we call data part. Okay, of course, to really have a working processor, you need to connect the inside memory to the main memory. Okay, so we have this upper bank. Upper bank, you have instruction register. Okay, and also program counter. This is 2 most important register in a processor. Program counter is necessary to specify the location of the memory. The memory store both program and data. Okay, you probably know roughly the organization of this kind of processor. However, I draw this one in particular to really explain the instruction of this processor. Not all the processor has the same design. All right. All this detail we don't have to concern at this moment. It's just program counter specify location of the memory, and instruction it is executing are stored in instruction register, and it is connected to control unit, which make the whole all pieces of this processor to work properly together. Okay, so this is inside part. That means data from register go to operation and right back to register, and then load and store instruction just retrieve the memory into register, or read from register, or from the result of the operation right back to the memory. Okay. A general format of instruction of this processor is like this. We write it this way: operation and 3 operand. The first operand is the destination, where we store the result. And the next two is the source operand, is where we get the value to perform. Okay, this is all register to register operation, which is dominant type of instruction in this processor. I give you some concrete instruction. In this slide, I will paint all the assembly language in green. Okay, and the assembly language just like this. And the right-hand side of assembly language is mostly explanation what it really do. Okay, for this example, we have three registers, number 0, number 2, and number 4, and we add the value of register number 2 and number 4 together and store the value in register number 0. Most modern processor can execute this type of instruction in just one cycle, right? So this is a normal standard. So it's 3 address can be executed very fast. And if you include pipeline, you probably can do 3 or 4 of the instruction at the same time. The type of instruction available also divided in this kind of group: arithmetic, logic, control, and data. Arithmetic is to perform some simple arithmetic. So we have plus, minus, multiply, divide, and mod. The complex instruction we probably will not use, just to study assembly language, but right, because the processor has these instructions, so that's why I tell you about them. Okay, the logic we have simple logic like and or, exclusive or, and this is important. But we used to compare these two values equal each other, and not equal, less than or equal, greater than or equal. And control, very simple one. We have jump is true, jump is false, and these two used for function call, which will be more in detail next week. And the data, of course, most data just load and store. We are not going to mention these two yet, that perform operation on stack and then moving data from between register. I will get into more detail of the arithmetic operation. Arithmetic operation have two kinds of operand. The first one is simple one, is all register. The second one is the last value can be actual number. Okay, and because of the format of the instruction, this number can have the only 17 bit. All right, so we write the assembly code as for this kind of small number. We name them the immediate value, okay, which is kind of language used in assembly language programming. Okay. So this is called immediate value. Okay. And the same true for all other instructions have two forms of operation. One is with register to register. The other one is register to immediate value. Okay. And next group is a logic. Similarly, logic also have register to register and register with immediate value. You will see shortly why this immediate value is useful. Okay, when we start to do a simple 2 or 3 line program a bit later on. So we have this operation of and, or, exclusive or, equal, and etc. and many other. Okay, just I did not show it here. Right? The more complex group is a data group. For this lecture, we need only 2 kinds. The first one is specifying the address. It is we call direct address. Okay. And the other one is indexing. direct address used to get the value from a scalar for one value from the memory. And if you have stored that information in terms of array, then you need two values. One is the location of that array, and the next is the number of the index, right? The element, the index to into that array. Okay, so we need two value. So we store both value in register. Okay, and we use this kind of notation. It's a plus, right? So distinguish between these two kind of we call addressing mode. Okay, the way we compute the location to get the value. Okay. You can see the meaning here. Like the direct address or absolute address is just using this number as the address of the memory. However, for index, we use two register and adding the value together to become the so-called effective address. Okay. We also have the third addressing mode, which we can, rather than specify the register, we can specify small number. Okay. We almost not use this in this lecture. Okay. And vice versa, you can you get information from memory. You can also store information from register to the memory as well. Okay. And writing is the same. The difference is in the operation code. So to move the value between two registers, we write it this way. And also we can move the small number into register. Okay. Right. So this kind of immediate value. So for example, this move R1 with M can be called move immediate. The last group of control is just a jump. So in this processor, the control type is very simple. It's a unconditional jump. So when we jump to some address, the program counter will be set to that address. So the next instruction will start from that address. Or if we want a conditional, we can test the value of flag. The flag will be stored in one register. You can specify which register you want. And then if that register is, this jump is true. So if register is not false, I mentioned the false value in the beginning of this lecture. If because if it's true, then we jump. If it's not true, then we do nothing. Okay. Similarly, we can jump if the value is false. For the last two, this is used for calling, to do function call. Right. So let's explain it when we encounter it next week. Some special instruction also include in this processor. We can use stack operation. We can push or pop. To use this operation, we also need to say we need two value from register. Okay, one is what value to be pushed, and the second is where the stack is. So we call one register R1 as a stack pointer, is point to the memory where we keep our stack, and R2 is the value we want to push into the stack. Okay. Similarly for the pop, and we have the last instruction we need to understand is the special instruction to stop the simulation, to print the value of register on the screen so we can inspect it, or if we want to print the value as a character. So we can use the trap. So we have three special instruction: trap 0, trap 1, trap 2, right?